I had a question about rate of change. So I want to go over this with a graph. When you're looking at a graph and trying to find the rate of change, you can kind of get a hint by looking at the title of the graph. Most often, the rate of change has something to do with the title. So in this case, look, fuel consumption of a smart car. In this case, it's very likely that the rate of change will have something to do with the fuel consumption. So what we're doing when we're finding the rate of change, we're comparing the changes in the dependent variable, which in this case is volume of fuel in the tank, and the independent variable, which in this case is distance in kilometers. So what you would first need to do is identify 2 points on your graph. And it doesn't matter where they are, but in this case, we are actually given a point here, and there's another marked point here. So I'll use these for the sake of this question. So the first thing we're going to do is look at the change in the dependent variable, which is the change in y. And this symbol is delta in math representing change. So what we do, comparing these 2 points, we're looking at how they change along the dependent variable values from here to here. So if you look, initially this smart car has 35 liters of gas, and then by the end, it has 0 liters of gas. So the change in y, we look at our endpoint first, which is the one that's farthest to the right. So that is 0 liters, and we subtract 35, which was the initial or the very first point we looked at. So this is negative 35 liters of gas. So we're saying the change from one point to the next, this smart car lost 35 liters of gas. That was the change, and we always subtract. The change in the x, we look along here at the independent variable values. So again, looking at these 2 points, initially when the car had 35 liters of gas, it hadn't driven any kilometers. But by the end, it has driven somewhere between 550 and 600 kilometers. So since it's a little way past halfway between these 2 points here, or between these two data values, I'm going to say it's probably about 580. So the second point was 580 along the independent variable, and the initial value was 0. So again, here the change in the dependent variable, the change in the independent variable, or x, was that this smart car drove 580 kilometers. So the actual rate of change doesn't look at the changes separately, it actually will compare them together. So the rate of change is this. It is the change in y divided by the change in x. And the rate of change will have units on it. So the change in y, if you remember, was here, negative 35 liters. And the change in x is 580 kilometers. So if you divide these, we won't leave it like this unless we could really simplify it as a fraction, but we'll just divide these. We would get negative 0.06 if we round to the hundredths place, liters per kilometer. Oops, I'll slide that over a bit. So here's our answer. This is the rate of change. So what we're saying is that when this smart car drives, it loses about 0.06 liters for every kilometer it drives. This is the rate of change. So we're just, again, the rate of change compares the overall change in the fuel consumption of this vehicle.